Okay, good morning. So let us start our class. Okay, well, right. Okay, so in previous class, yeah, we have seen the applicability, the pros and cons of what we call it as our landfills was taken in previous class. Okay, now let us go through the next topic, that is your deep well injection. Okay, so what do you mean by deep well injections and how we are going to be taking care of these deep well injections in our waste management? See, as the word itself says that you are injecting the waste, right? You are injecting the waste deep in a ground level, right? Below a very deep ground level. See, whatever we have seen till now, right? If you consider those disposal methods, right? If you have taken with respect to landfill and all, right? If you say landfill was excavated somewhere like what do you call it as uh, land was excavated to a very shallow depth, right? Wherein which we had laid that with some depth of 2 meters to 5 meters, right? 2 meters to 5 meters was to be the depth to which we have excavated, thus depending upon the capacity of the landfill which you have decided. And later on we are going to be covering this with a layer of soil, right, at a shallow depth, right? This is what we have seen with respect to the basically landfill. So when we're talking about a deep well injection, we are taking the waste, we are injecting the waste to a very higher depth, right? So deep well injection is basically a process wherein which we are disposing a liquid waste, right? Or we are converting the waste into a liquid form by incineration or by burning them with a high temperature. Then we are forming them in a form of liquid. Then we are going to be injecting them to a very deeper depth, right? This alternative use of injection well is to place treated and untreated waste, right, into a geological formation so that they don't have any potential to allow the migration of contamination to the potential potable water aquifer. The only reason why we are doing that one is that we want to avoid the contamination of groundwater. Whatever the groundwater is there, right? See, if you are having a ground level, if this is the landfill, of course your water table will be at this level, right? So at this level you shall be having your water table. So the chances, the probability of contamination is going to be too high, right? So in that case, what we do, we convert these what you call it as waste into a liquid form. Then we are going to be injecting by deep drilling and method. We are going to be excavating, or we are disposing them in a form of a liquid to a very deeper depth. If I dispose my waste to the geological formation of the earth at this point, if I'm what you call it as disposing my liquid waste, so what happens, since water is hold it up in this aquifer, in this layer, so there is very less chance, or there is no chance that this waste is going to be flowing upward because of the what you call it as your flow property. It is not going to be flowing upward, rather that is going to be flowing downward. So what happens here, the chances of contamination get reduces, or there is no chances of contamination of your potable water. Let us say this is the dimension of water which you have in the area. Let us say this much is the portion of water. So basically this is entrapped at a impervious layer, right, or impervious rock of rock. It has been, the water has been trapped, and this water have been used for drinking purpose. So in that case, the waste you have disposed to at a very deeper depth, this waste is further going to be going deeper into the geological formation, but it's not going to be coming upward, wherein which the contamination is going to be prevented. The contamination with the potable water is going to be prevented. So this is what we define, or we mean by our deep well injection. So in this, a typical injection well, which is consisting of concentric pipes, right? which extend to a several thousand feet down from the surface level into a very highly saline permeable injection zone that are confined vertically by impervious strata. Like if you see a figure, right, in that figure, we are going to be having a clear-cut idea of how we are going to be disposing our waste in a form of a liquid by deep well injection technique. So what we are going to be doing, we are going to be injecting them through the pipes, right? These are the pipes which you have the waste. These are the pipes, right? These are the pipes which you have the concentric pipes which you are going to be using, which extends to a depth of 1,000 feet. Very see, when we are talking about the water level basically exists at some 100 feet, right? Okay, like we say that 400 feet, 500 feet, 600 feet, that's going to be more than sufficient, or maximum 1,000 feet. But this is going to be deep excavated, or this is going to be drilled further deeper to a shallow depth to a several thousand feet downward, wherein which the surface level is going to be highly saline. It is going to be where it has a permeable zone, or where you have an injection zone, we have impermeability which is entrapped with the impermeable zone. Okay, so it is going to be confined. Further, we are going to be confining this. Confining means we are covering them vertically with the impermeable strata so that it should not be percolating to the sideways when you're going to be excavating this one, right? Okay, so you are going to be doing this method. So let us understand with the figure, right? So let us understand first the what do you call it as our figure. This is the tubing gauge, right? You are going to be measuring, right? You are going to be understanding, right? How much the dimension of this, what you call it as your inserting of the liquid waste is being taken into the consideration. Then you have annulus gauge, which is being installed at the top portion so that you can understand the what the intensity and the amount of waste which is being drilled off, or which is being inserted into the your deep well injection technique. And this is the point from which wastewater is nothing but the waste which is converted into the liquid form. Then you have a drilling process wherein which you are going to be drilling this to a several depth. This depth is going to be to several thousand feet, right? To the several thousand feet you are going to be what do you call it as drilling, which reaches to an impervious zone, right? In this impervious zone, right? Impervious means if you inject that one, that is not going to be getting percolated, or then the permeability is going to be zero. So you have an impermeable zone wherein which you are going to be injecting the waste which has been converted. So till this point you are going to be excavating, and from this point with different perforations which are going to be provided to the surface of the what you call it as pipes, the waste is going to be led into these geological formations, right? So up to the point, to the where you are going to be excavating, or where you are going to be extruding your waste, till then you have two perforations you are going to be providing, two layers vertical confinement you are going to be providing, so that the waste in any case should not be having leakages, or there should not be any leakages which is going to be provided. Hence we are going to be providing them a casing, right? Casing is going to be providing. So this is the injection tube which we are going to be using to inject the from where the waste is going to be traveling. From there you have a casing which is going to be providing. This casing is used for the time of excavation, the inner casing, the surface casing which are going to be taking place, and over that you are going to be having the different zones of the geological formation you have, right? Then later, once let us say we have certain amount of waste which is going to be there in the form of liquid, you are going to be injecting them. Once it is going to be reached to the impervious zone by the pressure, or by the injection amount of pressure injected, this waste is going to be getting traveled into this impervious zones, into the what you call it as deep cracks or deep voids of this injection zone. It is going to be getting, once it is going to be filled, or once the amount of waste is going to be filled, then we are going to be sealing them with the packers, right? A packers is provided so that the waste should not be exited, because this layer is already an impervious layer, so there is no chance that it is going to be coming from this way. Only from the point where you are going to be putting the waste, it should not come. So we are going to be putting the packers to make sure that everything is going to be good. Then later we are going to be removing this casing. Then we are going to be sealing this top, right? This is how we are going to be using our deep well injection techniques, right? Okay, then. So this is how what we have seen the deep well injection technique. So in this, as we have already discussed that the outer pipe and casing extend below the base of the ground level or underwater surfaces, water surfaces. That is what we call it as USDW, that is underground source of drinking water. And we are going to be putting cemented back to the surfaces to prevent the contamination to all this underwater surface. We are going to be putting an impervious layer. Either it may be with respect to the cementing backing, or either it may be have any other impervious coating that can be coated so as to prevent the percolation, the entry of water or any other fluids from the pipe to the location, or from the location to the pipe. We want to avoid the contamination of this one, entry of this water or any other liquid to this pipe, or from the pipe to the other liquid. We are going to putting them with the cement. Then directly inside the surfaces, casing is long string casing that extend to and sometimes into the injection zones. That is what, up to the point of injection, it is going to be, this casing is going to be extended, and at some point even this casing goes further deeper into the if the area is going to be certainly is going to be somewhat impervious, then this is going to be getting inside the injection zone. This casing is filled in with the cement all the way back, so that the surface in order to seal up the injection waste which is going to be formation, which is going to be filled, and the formation of the injection back to the surfaces. Once this packer is being filled, once this injection process is being filled up, or this deep well purpose is served, then we are going to putting this with the packer, and up to the complete point we are going to be filling this strata with the cement or any other backing, so as to avoid the entry of either water from here or exit of this in any case to the top surfaces. We are going to be doing this process, right? The casing provides a seal between the waste in the injection technique and the upper formation, so that nothing should be falling from upper to the inner surface of the load. The waste is injected through the injection tubing. That is what we are going to be using. From the tubing gauge, we are going to be measuring how much amount of injection is being inserted in the area, right? From the injection tubing, we are going to be analyzing how much quantity of waste has been injected, right, inside the long string casing, either through perforated in the long string or in an open hole below the bottom of the long string. At this point, right, you can see that at this point, right, at this point, either it may be a perforation, right, the perforations as it has been shown over here, either the perforations might be provided, or with only one end point it can be taken, and as an injection they are going to be injecting, so that all the waste can be what you call it as injected at the deep well, or at the end of the deep well. So the space between the string casing and the injection tube is what we call it as the annulus gauging. Annulus gauging, the space which we have between the string and the injection tube, right? There is a gap between the string and the gauging tube, the string and the gauging tube. That gap is what we call it as the string. This is the string and the tube. That is what we call it as the annulus gauge. This annulus gauge depends upon the size of the well which you are going to be calling, and is going to be filled with an inert pressure fluid, and it is going to be sealed at the bottom by removing the packers, preventing the injection of wastewater back portion into the annulus area, because there are many chances that during an earthquake or during any upward pressure, the water might be coming out of surfaces with which the wastewater which has been injected at the bottom can be coming out this one. So the gap which is going to be formed, the annulus gap which are going to be forming, those annulus gap are also filled with other cementing materials, right? This is how deep well injection is going to be taken up place, but we do have some applications and need to have some disadvantages. So the disadvantages and the applicability part we are going to be seeing over here. So when we are using these injections, we are going to be always targeting the contaminated groups, right, which are going to be which are basically volatile organic compound or semi-volatile organic compound. Volatile and semi-organic volatile compounds means what? The compounds or the liquids which can evaporate at a faster rate, but they are not dissolved in water. But they cannot be dissolved in water. For example, let us say a grease and a oil from a what you call it as our automobile industry, right? If you are exposing or if you are just discarding that into a surface water, so what happened? They're neither going to be dissolved in water, and once they are in contact with the water, they are going to be evaporating at a very slow rate. So what happens at that time? The contamination, what do you call it as these volatile fluids and volatile liquids, if it leads to very harmful effect on the aquatic life if they are going to dispose on the water bodies. Hence, to avoid that one, we are going to be deeply injecting them, right? So basically, we are targeting the what you call the deep injection techniques for VOs, SVOs, that is volatile organic compounds and semi-volatile organic compounds, either maybe fluids or explosives or pesticides, which are going to be harmful and they're not going to be easily dissolved in water, but they are going to be easily evaporated. However, existing permitted deep well injection facilities are limited only to narrow range of specific waste, right? Which are going to be basically they are going to be hazardous waste, right? So as to expand or so as to intensify our exposure or disposal for the hazardous waste, they are going to be very much preferable. But nowadays, since of the hazardous nature of the compound, we are going to be not preferring to go with the deep well injection process, right? So there are going to be some application effects that are going to be used in this process technique. So injection will not be used for hazardous disposal waste in areas which are seismic activity could occur, potentially occur. See, if you have a seismic zone, that means that where you have a area which is prone to earthquake and all, at that in those areas we are avoiding the disposal of hazardous waste in this deep well injection technique. Reason is what? Because whenever there is seismic activities, it leads to liquefaction of soil or liquefaction, because of which the water is going to be flowing onto the top surfaces because of the liquefaction. So if the liquefaction occurs, there are all the chances that these waste which you have disposed to a shallow depth in the ground level, those can be coming out from the area or from the voids which are going to be forming because of this seismic activity. Hence, we always avoid that these disastrous or hazardous waste should be avoided or should not be coming out of the what we call it as earth surfaces. So what we do, we avoid, right? We take all the measures to use the injection or we use or we curtail ourselves for the injection process where we are going to be not using in a what you call in a seismic area, right? Then as we have told you that injection waste must be compatible with the mechanical component of injection well system and the natural formation of water. It means to say that you should have some liquidity or some flow property should be there. It should have some flow property so that the mechanical component of injection, whenever we are using it, if it doesn't have any flow property, then it becomes very difficult to operate the injection technique. So it see, in a syringe, if you take a solid and apply the pressure, the amount of intensity of the pressure might be less. Hence, what we can do, we can go for what we call it as applying more we end up with applying more intensity of pressure to inject the waste. Hence, what we do, we want to make sure that it should have some mechanical component, it should be kept compatible with the injecting instruments which you are going to be using. Then, the waste generated may be required to perform physical, chemical, biological, or thermal treatments for removal of contaminants or constitution of waste to alter or to modify the physical and chemical characteristics so as to make them safe against the compatibility. See, you cannot use extreme what we call it as hazardous waste for disposal in this method, because whatever the waste we are using over for disposing in this deep well injection technique, it has to be given some treatment so as that, because once you inject it within the ground, you don't have any control of further what you call it as flow of waste into the ground geological formation. Hence, if they are too toxic or if they are too harmful, some basic treatment has to given in that, so that it is assured that if at all at any point of view, if because of any consequences, if there is going to be some contamination, it is going to be having less hazard, less effect on the contamination part, and also the waste should be, it has to assure the compatibility. That's all what we want to say, that it should have some compatibility. Then if it has a high concentration of suspended solids, which is going to be more than 2 ppm, that is parts per millions, so it can be leads to plunging of your injection interval, like, because it takes more time. If you have a solid waste, it will for what you call this injecting and hot, it will take more time. So hence we are going to be avoiding those butters, or we are going to be taking take care of these things. Then corrosive media can react with the injection well components, like if it has a chemically highly corrosive some components are there in the waste, then again the medium becomes corrosive, then it becomes very much difficult, because any part of the injection is going to be, if it is going to be corroded, we cannot know that again the complete injection system is going to be becoming ineffective. Hence we want to make sure that the formations which the components which are going to be taking, it should have less reactive with the corrosion, and also with the confining strata with the undesirable results, because if the what you call it as components are not behaving as per the expectations or as per the working condition, of course the working system of this is going to be getting affected. Hence you want to make sure of this one, and waste should always be neutralized. That means that it is not going to be affecting the instrument, or neither the point at which they are going to be getting disposed. Also, the high iron concentration which are there, in many cases this happens because of the different variety of components which are present in the waste. High iron concentration may result in falling, wherein which you are going to be having insolubility with the soluble compounds or other what you call it as system. So we want to avoid this cases. Then organic compounds may also serve as energy force of injecting bacteria, which results in rapid population growth and subsequent falling of the components is going to be taken up in the waste. So we want to avoid this one. Then waste stream, which is containing organic uh, contaminants above their soluble limits, may require pre-treatment before injecting to a well. That is also what we are going to describing in this one. Then site assessment, then aquifer characteristics to the point where we are going to be injecting. So simply you cannot take the waste and inject to any depth, right? We need to understand, right? We need to understand to what depth we have to have, what is the accessibility, right? Whether it has a source of water, or what is the level of groundwater surfaces over there, or whether the water which is available in the area, whether it is going to be too what you call it as pure, or what, or to, at a very high level, or what, or which depth it is going to, that is what the site assessment has to be done. And the aquifer characteristics, that if aquifer is going to be getting extended because of this getting contaminated because of this defill injection technique, so we have to avoid this area. Then extensive assessment must be complete prior to receiving the approval of the area or area authorities, what we are going to be taking for the technique. See, the only, you need to understand this thing. It's like why we are going to be going with a deep well injection technique is that the liquids or the components which are in the form of a liquid, so should be injected to such a depth in the geological formation that they should not form, or they should not leads to any harmful contamination or effect either on environmental, that is either on soil or water, or on the human being. But if you are not, so that's okay. So how we do that one? We are going to be just injecting them to a geological formation from where they are not going to be coming out. That is what the consider, right? But if the injection process is not proper, so what happens? They may get coagulated, or they may get the complete injection system gets failed at some point. So you cannot plunge it out, or at that point only you have to leave the waste. So we want to make sure that all the application and limitation part is going to be dealing with this one only. We want to make sure that everything should be pre-treatment, and it has to be have some flow property, that the injection process goes well, and also it should not affect the site, right? It should not affect to any area where the injection has been placed. So it should not affect neither the water, neither the soil, or neither a geological formation near the area. Hence, you have to make sure that all these requirements which have been stated above is being referred or is being taken care of. Right? This is what we basically deals with the deep well injection technique. Right? Okay. Now, moving forward. Okay. Okay. Then you have the next topic is material recovery facility. Okay. Right. I hope you remember one thing that the amount of waste which we are developing, right? If it decreases the amount of waste at the source itself only, then the amount of load or the intensity what you're going to be carrying upon, or the load pressure which you're going to be carrying upon your management system is automatically going to be getting reduced. It means to say that that can be done by reusing and recycling. By reusing and recycling your waste, you can do that. In that, you have our basic methods. That is what we call it as material recovery. Hence, we need to understand in this topics how a material recovery has to be done. So this is what the process which you are going to be using in a material recovery. You need to understand this complete process, right? This complete process is what a material recovery. Okay, how we do this one, right? Okay, let us take. We have a waste which you have collected from the source. Let us say the waste comprises of paper, glass, plastic, and metals. And let us say that we don't have any what do you call it, a separate collection system or separate collection from the source. Now we have the waste which has a component of paper, glass, plastic, and metal. So in a recovery system, we are going to be separating that. How? They are going to be led on a conveyor belt. From a conveyor belt, we are going to be taking them on a conveyor belt. This conveyor belts, all the waste which is present over there is going to be what you call made to go or made to pass from a air suction system where air shorting is going to be done. So what do you mean by air shorting? Because a suction what you call it as air is going to be developed, intensity of air is going to be developed. That air is going to be sucking the material which is going to be having lighter in weight. Like for example, the papers and all the cardboards and pieces of cardboards and light weight material like plastics, light plastics, carry bags are all going to be sucked over here. That is what we have air shorting. In this air shorting, the material, the waste components which are lighter in weight are going to be getting segregated. Then in the next step, the conveyor belt, the material is going to be moved forward. When it is going to be moved forward, you have a magnetic separator. This is going to be the belt. This belt is going to be moving this way. So what happens when all this is a magnetic belt, right? This is a magnetic belt. This has a magnetic in this one, right? So what happens when the waste is going to be coming at this point? Let us say there is a metal, right? Let us say then you had a metal or an iron piece which was there. So what happens because of this magnetic property? It is going to be attached to this belt. It is going to be getting traveled over here, and it is going to be thrown at this point, right? At this point, the magnetic attraction is going to be decreased. Hence, the magnetic is at this point only. Hence, they are going to be getting dropped over here. Then the further waste is going to be traveling forward, right? Traveling forward, in which they are going to be made to fall from a height. Because of this falling, whatever the materials which are going to be heavy in plastics and are going to be shorted off or are going to be taken up from there. Then you have the segregation of paper which are going to be taking depending upon the characteristic property. They are going to be blowed with the intensity of air. All the papers is going to be shorted out. Then they are going to be made to fall, where in which the glass particles which are going to be having some optical segregation, by optical segregation, then we are going to be getting removed off. Then the further processing is going to be taking place where you have the segregation. Either you can be doing a manual segregation to remove the stone bottles or stone petals or different components of the stones are going to be getting removed. Then the further it is going to be traveled, the further waste is going to be traveled, where in which you have hammer wheel is going to be crushing them. The waste which are going to be closer in dimension are going to be crushing. Then again that is going to be sieved off. Then again that is going to be the crop, plastic and papers are going to be taken to other part. Then other which are going to be coarser in dimension are going to be taken, which are going to be finer in dimension are going to be taken. Again, the segregation is going to be taken place. Like this, we are going to be going with the material recovery property. So this is done because we want to make sure that what are the waste which we have over there, all this waste has to be properly recovered, because we want to make sure that the available amount of waste to be disposed should be less, and the other materials which can be recycled and which can be reused can be taken up, so as to decrease the load or decrease the intensity of the load on your landfill or any other disposal methods. That is what we are going to be doing in our material recovery. This is all we are going to be saving. So okay, so let us go with the introduction. So what do you mean by a material recovery? Excuse me. So a material recovery is nothing but a specialized or is an equipped facility, right, wherein which you are going to be taking care of, right, three components. What are those? Wherein which the facility, you have a plant, specialized plant, wherein which you are going to be receiving, you are going to be separating, and you are going to be preparing the recyclable material for marketing to the end user manufacturing. See what I do, we take the paper, right, we are going to be recycling that paper. Before we recycle, the recycling system is going to be something different. So we are going to be taking the paper, we are going to be, see, from a waste we are going to be receiving the waste, then we are going to be separating that paper, we are going to be preparing that paper, and we are going to be sending to the end manufacturer. So these manufacturers are going to be converting that waste, the used paper, into a other form of a usable material. That is what we do in a material recovery, right? So this material recoveries are basically, material recovery factories or facilities are of two process. One are going to be the clean manual methods, clean mechanical methods which are going to be using. Another one is going to be the manual method. That's what the dirty methods or dirty waste recovery waste or unhygienic materials which are going to be recovered. Okay, so here in the figure you can see that there are certain bags, right? We had a jute bags and all that has taken and that has been converted to some other forms, right? There are cork, there are glass bottles which have been taken and which have been reused with some designs. That is what your clean material recovery facility. All the material which is going to be clean is going to be taken up and is going to be recycled or reused to other form, to other type of the waste, right? That is what we have. A clean MRF. In a dirty MRF, this is what the composite material is going to be taking, and you take the other process. Then the process, once we separate that one, here individuals are going to be separating, then the separated materials are going to be sent to the end user for manufacturing and generating some other byproduct or some other product for the further users, right? So the principle of our material recovery facility is that the mixed solid waste are separated based upon their source of recovery of material. Because see, as we have been telling that every source which is going to be generating the waste, the components or the composition of these waste are going to be different. See, you cannot say that there is always going to be paper, there is always going to be plastic, there is always going to be glass, there is always going to be metal, or there is always going to be sanitary waste, or there is always going to be waste from the vegetables and fruit. This composition depends upon, right, is based upon what? Is based upon the source. Hence, the complete material recycling facility is depending upon the source from which you are going to be collecting the waste. Hence, mixed solid waste are separated based upon their sources of recovery of material. How we are going to be recovering that one, how the source we are going to be getting is done. So it depends upon the degree of source separation of waste. So as you modify or as high as you intensify the amount of what you call it as the processing techniques or processing waste, then this is going to be leading to much effective separation technique. Because if you have a poor separation technique, if you have less components, you have less separation recovery factors. Then the national and the design of each unit process accommodated accommodate the physical and the chemical characteristics of the source material depending upon the various depending upon the component, the physical and the chemical properties are going to be changing. So with the variation in the physical and the chemical property, even the nature and design of the unit is going to be based, because if you have less variation in physical and chemical property, you have less design and units, right? Then the resource recovery plays an important role in economical developing economics of the developing nations, because what happens if the resource which are going to be recovering are produced from a very highly recoverable or recyclable facility, then the unit or the plant which are going to be establishing will be of a lower cost, because there you require only small amount of financial assistance, right? If it is not going to be having any complex sources, if the amount of sources or the complexity of the source is too high, at that time it becomes very much difficult to have or it becomes very need to have one complex method. So according to that one we are going to be designing. So the principal design is based upon the source and the material which you are going to be collecting from the source itself, right? Okay, now in your material recovery facility we have certain techniques, right? So these techniques might be classified. One is what we call it as mechanical method, and the second one is what we call it as a manual method. So the word itself differentiate the mechanical and the what we call it as manual method. So what do you mean by mechanical method? Of course we use some instruments, right? These instruments are going to be separating our waste. In the manual methods we are going to be using manual manpower, or we are using individuals, we are deploying individuals to separate the waste, right? So like this we are going to be separating the MRF. This is what you have, your manual separation method or manual segregation method which you are going to be using. So in this method what happens, you are going to be deploying, right? You are going to be deploying humans, right? Humans are going to be deployed so as to segregate the waste which you are going to be taking by manually, by hand picking. You are going to be doing this one, whereas in a mechanical method you take different methods, different systems such as electromagnetic segregation, then you have fluid dynamics, then you have pneumatics, and the other criteria, other parts, other techniques you are going to be using manually, or with mechanical means you are going to be going for the separation of the waste. That's what we are going to be using with the mechanical method. So you do also require in mechanical method the process of size reduction, air classification, that screening is going to be done. This is how we are going to be taking a brief manual method that we shall see, right? When we come to the explanation, we will have this detailed explanation of part number 1, 2, 3, 4, 5, how we are going to be doing this one, right? Okay. So in manual segregation or manual processing, what you do, like the bulking items, right? You have appliances, you have furniture which are very easily can be picked up, we hand picked up, and some specified contaminants, especially which are going to be hazardous in nature. Let us say you have some what do you call it as a medical waste which is going to be there, or a human animal parts, or animal body parts, or human parts. So those are going to be easily picked up. The bulk items are going to be getting picked up, and basically then also the specific contaminants are going to be removed. This is applied, the manual application is applicable to the removal of contamination for the source or source separated material, or at the point where you're going to be using for the collection. That can also be done at this point, right? Equipment do involves in the manual separation. Usually you have a belt from where you are going to see, you don't have any all the complex instrument, right? You have simply, you need a platform, you need a conveyor belt wherein which your waste is going to be continuously flowing, right? See what you have a conveyor belt. Some individuals might be standing over here, right? Some individuals might, let us say some individuals are standing over here, right? So they will not be moving this conveyor belt which is there. The conveyor belt is going to be moving, and the waste on the conveyor belt is going to be getting continuously moved, right? So what happens, all the waste which is there, they are going to be hand picking the waste depending upon their properties. So it do require some instruments that might be a sorting belt or sorting table, or the sorting platforms which contain the mixture of material. That's what the point or the location at which the waste is going to be thrown off. Then you do require hoppers and other receptacles for the receiving or removing items which are supposed to be positioned for that, because once we remove that one, either they have the hoppers which is going to be continuously dropping the waste, and you have different baskets and containers which are going to be removing the collected waste. So this is how we are going to be doing. So when you're taking the manual processing, basically if you have the segregation, approximately 700 to 4,500 kgs per hour a person is going to be removing when you have a waste which is comprising of newspaper. Then you have corrugated waste, you have glass containers, whether it may be mixed color or a bicolor, it reduces. Then you have plastic containers, aluminum containers, all that can be removed with some intensity. Those intensities being mentioned over here, the process how we are going to be doing. See, this depends, right? If this is the waste, but if it is too, let us say, if this is the waste, if this is only comprised, this can be removed in 1 hour. Let us say the aluminum cans or the plastic containers or glass containers, corrugated and newspaper, they are going to be removed manually. But the intensity far increases if you are doing using a mechanical means in this recovery method, right? Then you have mechanical suppression. Mechanical suppression involves size reduction. You're reducing the size. Then you have glide suppression. You have air classification. Then you have non-ferrous suppression. Of course, with the magnetic suppression is there. Instead of magnetic suppression, whatever you are doing here, that's going to be non-ferrous suppression. Then you have screening depending upon the dimension. Then you have densification, where you are going to be packing the waste into a compacted form. You are going to be compressing. Then you have magnetic separator, where you are going to be removing all the metals. Then you have conveyors, which is going to be used to transport the waste, which is going to be collected with different process, right? Again, you have this basic, okay, that we tell T. Okay, so right. Before we go, let us understand the size reduction. See, this is what we have called it as the size reduction. Can you see over here, right? This was your cold drinks bottle, right? When they are going to be crushed, this is going to be forming, right? At earlier, one bottle of beverage can is going to be taking this much area, but in resizing, what happens? This is the change. You are going to be compressing them, right? You are going to be resizing them, or you are going to be decreasing their size either by compression or by cutting, or either by any proper techniques or proper methods which are going to be using. That is what we call it as the size reduction. As I told you, the size reduction, it's synonymous to many different definitions. We can call that as shredding, where in which you are going to be cutting, and they also call it as grinding, where you are going to be reducing, or we are going to be decreasing the dimension of the waste, right? So reduction reduces the size reduction. It reduces the bulky items to particles, right? To smaller particles, the sizes of which are compatible with the processing equipment. So you have different processing equipments. So all the sizes of these can easily be comprised, or are going to be easily compressed to a lesser sizes, so that it can easily be handled by different equipments which are going to be using in the techniques or in the method of our recycling and recovery, right? This uniformity is a requirement of some mechanical sorting methods, or it is prescribed, or it is going to be specific, because if some instruments are there, those instruments might not be suitable for operating the waste which are going to be coarser in dimension, or which are going to be what you call it as wider in dimension. Hence, you require the uniformity of this mechanical sorting is going to be a need. Then you have the hammer mill type is a high speed cutting machine or shredding machine, which is frequently used for this size reduction, right? Because it is going to be continuously cutting. Then you have low speed, high torque, what you call it as fail mill type shredder and shear shredder that are used in some cases to reduce the dimension of the solid waste by different soil reduction on the basis of orientation of a rotor, namely either it might be horizontal or vertical. We are going to be classifying the instrument. This is your horizontal hammer mill, right? So in this, what we do in this, how does this work, right? Simple, right? You have a waste, right? You have a waste which is going to be brought in, right? You're going to be putting the waste over here, right? Once you put the waist over here, right? This waist, it is going to be made to travel in the clockwise direction when it is going to be moving, right? Right, in the clockwise, sorry, anti-clockwise direction when it is going, the waist which is dropped over here, this waist is taken or brought to this breaking bar, right? This breaking bar. So when the waist comes at this point, this is the hammer, right? This is the hammer. This doesn't moves backward or forward. It simply brings the waist and it compresses the waist near the breaking bar. Automatically, it is going to be getting crushed or it is going to be getting compressed. When it is going to be compressed, it is going to be moved. As the rotor disc moves, the waist is going to be moved, and this hammer leads to crushing of the waist, and this waist is going to be collected from this point. This is what we are going to be taking. Some waste which are not going to be used, some metallic waste are going to be collected at this point, or else because of this size opening, the waste which was there, that is going to be getting separated, right? The metal waste which was trapped over here, then again comes over here, or say magnetic this one, this is going to be getting and rejected from the area, and the waste which is going to be crushed to the required gradations are going to be sieved off from this bars, and this is going to be collected in the downward direction. So this is how your hammer mills is going to be working, where in which it is going to be reducing the size. Then you have vertical mills, right? In vertical mills, what you do, you are feeding the waste, right? You are feeding the waste from the top, then it is going to be made to fall, right, from one rotor disc to other rotor disc, which is provided with the hammers, and on the central shaft it is going to be provided with the hammers. So what happens, the intensity which it is going to be rotating, it crushes all the waste, and the waste is going to be discharged. So as it waste moves downward, it is going to be getting finer and finer and finer and finer. Based upon this one, it is going to be getting crushed, and it is going to be collected in the discharge well. Then you have shear shredders, right? See, you might have seen these machines. You bring up, you take any machines, you put over here, everything is going to be getting. This is also used for size reduction, reducing mixed waste, which can be used, or simply you can throw over here, right? You have what you call it as your two blades or two hammers. One is going to be rotating in an anti-clockwise direction, and the other is going to be rotating in a clockwise direction. So these are the cutters which are there. These are the cutters which are there, which are mounted. These are the cutters. So the moment you put a waste over here, from this side there is going to be cutting. From this side there is going to be cutting, and it is going to be leading to what you call it as resizing of the waste. It consists of nothing but the two horizontal counter rotating shaft. Each shaft has a container to tear and shear the materials. These are the cutters. Every shaft has this facility wherein which it is going to be cutting this one, right? This typically it rotates at a speed of 20 to 70 RPM. The shear cutter deforms the deformation are the primary mechanism for particle size reduction. We are going to be using them specifically to reduce the dimension of the waste, right? So this is what all you were supposed to study in today's class, right? So if you have any doubt, kindly ping me, right? And remember, what all has been taught, you need to be very peculiar, right? Okay, guys, thank you.